Chapter which we are going to begin today, the chapter name is Force and Pressure. Right. Okay. So whenever you see that an athlete who wants to throw a very heavy ball during shot put, you guys know about shot put now?
Yes.
It's a sport in which basically a heavy ball is it is thrown to a and is thrown as far as possible, right? So whenever a very heavy ball during shot put contest is being thrown, then what type of force is being applied? The person needs to push the ball very hard, right? So we say that the athlete applies a large force to the ball to make it move through a large distance, right? So a force of push is applied, right? Or see another athlete who is lifting a dumbbell, who is lifting a dumbbell. So in that case, what kind of force is being applied?
Pull.
He's trying to pull, exactly. He's trying to pull it towards itself, right? So that is basically the concept of force. Okay, see in this one, from two different sides, force is being applied on this piece of object here, right? And then we have another thing in the chapter. Ahmed, please mute yourself. There's some background noise. Okay.
Oh, sorry,
And
sir.
then another concept is pressure that we'll be talking about, right? Okay. So if you were to see the broad heel of a man's shoe, okay. So if you were to see the heels in the shoes, I guess this it looks like this. Basically, the heel in the shoes, heels of a shoe. Okay. So if the base of the heels of the shoes it falls on our foot, it hurts our foot too much now. Or if the heel of the shoe is broad and if it were to fall on our foot, it hurts much lesser. Why is it so? It is because due to broad heel, the force of man's weight falls on a large area of our foot. I'm talking about, let's say, that is a shoe. Okay. If the heel is like this, and there is another shoe in which the heel is like this. Okay. So if the person wearing a shoe of a very small heel, and if the person wearing a shoe which is having a broad heel, and the two persons were to step on our foot, in which case we will be hurt more? In case A or
With the
in
heel.
case B? The one with
A.
A1, right?
Yeah.
Because the surface area here is very small and the surface area is very big. So the weight of the person will be felt more in case A, because because the force of the body of that man is acting on a very small area, while in this case the weight of the person was distributed to a much larger area since the broad and since the heel was broad, right? That's why we were to be slightly less hurt in the second case. So that is basically the concept of pressure, that basically says that force acting on a unit area. Okay. So while discussion of force, whenever we will be considering area upon which it is acting, then we will be basically talking about pressure. Okay, so that was basically a brief introduction of the chapter. Okay, has Arhan joined or not? He's not here, I guess. Okay, is that clear to you guys? Hmm?
Yeah.
Okay. Now you see, force will occur whenever two bodies will either be in contact with each other, like here in this case, in these examples, there's a frictional force, there's a spring force, or there's a muscular force in which two bodies are in contact with each other, right? And there will be another type of force acting between two objects where in which case the two bodies
There's
won't
no
be in
contact.
contact with each other. Exactly. For example, magnetic force, gravitational force, or electrostatic force. All right.
Hmm.
So all these types of forces are used in our everyday action, right?
Yeah.
So like pushing, pulling, lifting, stretching, twisting, right? Like
Hmm.
pushing, pulling, lifting, or twisting an object, or pressing an object. All these type of different activities requires what? Forces.
Contact. Hmm.
Yeah,
Forces. Yeah.
exactly. Okay, so let's talk about what is force. Let's begin with this thing here. Okay, so when a push or pull is applied to an object, it is simply called as force. Okay, and what
Hmm.
can this force do? If the body is in motion, if the body is in motion, it can bring it to rest. If a
Yeah.
car, let's say it's moving, okay,
Hmm.
applying the brakes, we can bring it to rest here,
Yes.
right? Or if the car here is in rest, if the car here is in rest, then we can bring it to motion,
Motion.
applying force. So that is what a force can do. It can bring an object from a position of rest to motion, or from motion to rest. What other things it can do? It can also change the shape and size of the objects, right?
Yes.
That
Hmm.
is what force can do. Apart from this, let's say if this car is running a straight road, okay, now you applying force, we can change its direction also. It
Yeah.
was going in the east direction. Applying force, we can turn it to be moving in the south direction. Right. So force can also change the direction of the object as well. Shape and size, direction, and its state of motion, whether it's in state of rest or whether it's in a state of motion. Right. Now the thing here is that to let a force come into play, two or more objects must interact with each other. Notice the word here interact means here. So interaction basically here implies that the two objects need not to be necessarily in contact with each other. There should only be an interaction with the two objects, between the two
Hmm.
objects. Getting it, guys?
Yeah.
Okay. So either the two objects might be in direct contact or not be in direct contact, as an example of a magnetic force or electrostatic force.
Hmm.
Okay. Now, how do we measure force? It is measured using a SI
Newton.
unit, that is a Newton. And in short, it is written as N, right?
Yeah.
And if we were to find the formula using which we can find the amount of force, so force equals to mass, that is basically the weight of the body, into acceleration. Okay.
Hmm.
By the way, mass and weight, they are two slight different things. Mass and
Yeah.
weight are not same, huh?
Hmm.
Can you guys explain to me why? What is the difference between the mass and weight?
I don't have any idea.
Ahmed, you?
Yes, sir. The
The two terms often seems to be very confusing. Like this, they seem similar, but yet they are different. The reason is no. Look, if you were to stand on moon, if you were to stand on moon, and if you were to stand here on Earth, okay. Now we know that the gravity of both the planets are different.
Different. Yeah.
Exactly, they are different. The force of gravity, it is more in case of Earth as compared to Moon. Since the weight of the two bodies are different, the size of the
Different.
Earth and Moon are different here, right? So the force with which Earth pulls an object towards itself, it is 9.8 meter per second square, right? And it is somewhere
Hmm.
1.6 meter per second square for Moon, right?
Hmm.
So the force with which the Earth here will pull in the pull ourselves towards its center, that will be called as weight, right?
Hmm.
Okay. And let's say if I say that your weight is 80 kg, okay, simply I'm talking about the force with which Earth is pulling it pulling us towards itself, right? And this weight, let's say to be 90 kg. So if we were to stand on moon, if we were to stand on moon, this weight of ourselves will become 1/6. So on moon, we will feel our weight to be only 15 kg, since it becomes 1/5 of the weight on Earth. So that is the difference. While mass is the actual what do you say? Like our body is made up of muscles, bones, and different tissues. So it is the actual composition of all these types of components in our body that is basically equal to mass. Okay, so force equals to mass into acceleration. Acceleration, you guys know about this, huh?
Yeah.
Ahmed and Arham. Okay, so this is basically mass into acceleration. So the SI unit of mass is kilogram and acceleration is meter per second square. So it is kilogram meter per second square. That is basically the unit of force, or in short, we call it as Newton, right? So this
Yeah.
kilogram meter per second square is also called as Newton, and in short, it is represented by capital N. That is
Newton.
its symbol. Okay, so far any confusions?
No.
Okay, Ahmed.
No, sir. Sorry.
Okay, okay. Arhan hasn't joined yet, no?
Yes, sir.
Okay.
Yes, sir. He hasn't joined yet.
Okay, now there's a question here that do magnets also exert a push or pull, which we're talking about a moments ago? Yeah, they also exert a push or pull on each other. So you see there are different magnets that comes in different shapes and sizes. Okay, so there are bar magnets, horseshoe magnet, right? So there are basically two different poles in a magnet, that is a north pole and a south pole.
Yeah.
Right. Okay, in a
Sir,
magnet we
Arhan has joined.
okay. Yes, Arhan. Assalamu alaikum. Yeah, walaikum salam. Why are you so late, Arhan, in the class?
Sir, actually there was a jam at my place, so that's why
Okay, okay,
I
no issue.
ate.
Okay, no issue. We have just begun the chapter moments ago. Okay, we were basically talking about force. Okay. Okay, so we were talking about that. Do magnets also exert a push or pull? Okay, so if you were to place two bar magnets alongside each other, and if the poles are arranged like this, so in this case, north pole of the two magnets are placed alongside. So will the two magnets be opposing each
So
other
it
or
will,
attracting each other?
sir, it will
will
repel
repel.
since
Repel. Yeah. Since like poles repel each other, and unlike poles, yeah, north and south, no?
attract each other.
Yeah, it should be south here, north and south. Okay, so in the case of magnets, our type of force is acting that is called as magnetic force, right? And like poles we know attract, while the unlike poles, like poles repel, while the unlike poles attract. All right, now see this activity, and in this activity there are a number of activities, number of situations given in which we have to say basically either we applying push or pull or lifting the object. Pulling is same as lifting. Okay. Okay, so the first one, guys, opening or shutting a door. What different actions are required here? Like to open or shut a door is pushing, pulling, lifting, lowering, throwing, shutting. What are the actions required?
For opening a door, you have to pull, and for shutting a door, you have to push.
Yeah, pull then push. Right. Okay. Drawing a bucket of water from a well.
Pull.
Pull. Good. A football player taking a penalty kick. Ahmed.
Push.
Pressure, sir.
That is
Push.
push. Okay. A cricket ball hit by a batsman.
The push.
Push. Right. Moving a loaded cart.
Pull.
Pull, sir.
Moving a loaded cart. Okay.
No,
That is
push.
push, no? There is a loaded cart. That's a loaded
Pull.
cart. Okay. And we are basically trying to move it. So we are applying push here. And in fact, the question, since the statement is not clear, we might either be pushing it from this side or we might either be pulling it from this side.
Hmm.
Right. So both type of forces will be involved. Right. Pull and push both.
Hmm.
Opening a drawer.
Pull. The pull.
Pull. Good. Okay, that is pretty simple. That was simple. Now let's talk about the characteristics of force. Okay, like whenever we talked about force, what are the things that takes place? Okay, so here in this case, force is being applied in one direction. Okay, so when force is applied in a direction, in one direction, now the force is being applied by the two objects. Do tell me when this object will start to move. What is the condition required by this object to move? Hmm?
Sir.
The question is that here two boys are pushing this object here. Okay. Now, when will this object start to move?
So when they start pushing,
No, when the amount of push, when the amount of force applied by these two boys overcomes the frictional force. Yeah.
yeah.
When
Yes,
they are
sir.
applying a force greater than the frictional force that is between the
Hmm.
object and the ground, then only the
Yes.
object will start to move. So when force is
Yes,
applied
sir.
in one object, the object will move. Okay. When the applied force overcomes the opposing force, and in this case the opposing force is
Friction force.
frictional force, right? Okay. And also this force will have some magnitude,
Hmm.
has some magnitude, and it will have some direction also. Magnitude as direction as well. Now take another situation in which two boys are applying force on the same object, but here in opposite direction, right? One
Yes.
is applying on the left side, one is applying on the right direction, right? So now in what situation the object will start and in which direction the object will start to move?
The object will not move.
the, the object will not move.
Sir, the
So
object will move if the amount of force applied is greater than the amount of force applied by the other person.
yeah, let's say to be person A and let's say to be person B. So if the person A applies a force greater than the force applied by the person B, then the
Person A.
object will, yeah, then the object will start to move towards the person B, isn't it, Ahmed
Hmm.
and
Yeah.
Arhan and Arham?
Yes,
Yeah,
sir.
Hmm.
that is the thing here. So when two forces are acting on an object, the object will start on the side of on the side where the magnitude of force is lesser. So we say that when two forces are acting on an object in opposing direction, okay, then the object will move towards the side where lesser force was acting, right? That is towards the side of the person B.
Yes, sir.
All right. So the force will always have a direction. In this case, it is towards the person B, and it will also have a some strength, that is a Newton, or
Hmm.
that is strength, or whether we call it its magnitude, that will be measured in Newton,
Yes.
right? Okay. Now, what are the things that this force will do to the object? It might either change the direction of the object, it might either change the motion of the object, right? Or it might either change the shape and
Change the
size
shape.
of the object also. Okay.
Yeah.
Now let's consider a situation in which multiple forces are acting on an object. So consider this person riding a bicycle here. Okay. So
Hmm.
here, what are the forces happening here? Rolling resistance, right? Right. That is a
Yeah.
frictional force here. That is
Hmm.
also taking place between the tires and the ground. Okay. Normal
Yes,
force,
sir.
that is basically force of
Muscular
gravity.
force. Hmm.
Force of gravity is happening. Muscular forces are also there, and the wind resistance is also there, right? So multiple
Yes.
forces are taking place here. Let me write the directions here. So this is the frictional force, sorry, this is the frictional force here, right? And these are two normal forces here. Normal force is a type of force that always acts perpendicular from the ground in the upward direction. That is called as normal force. And there will
Hmm.
be the force of gravity also, that will be due to its weight. The force of gravity, that is simply the force by which an object is pulled towards the core of the earth.
Earth. Yes. Yes,
Okay.
sir.
Yeah. And its magnitude, we also call it to be weight. And then there
Hmm.
is wind resistance also, and the force with which the person is moving forward. So multiple forces are acting. So the
Hmm.
force which will be having a greater magnitude, in that direction the object will start to move. So in this case,
Yes.
this F force, that is in the forward direction, that in it is having a higher magnitude. Okay. That's why the person is able to move forward. So basically, this force has overcome the wind resistance, the rolling resistance,
And
the
friction force.
weight, and the normal force. Okay,
Hmm.
guys. Okay. So the effect of more than one forces being applied on an object is calculated by evaluating the net force acting on that object. So you will have to calculate the net force. So net force will be calculated like this: wind resistance, okay, plus this F plus this normal force plus the weight of the person, right? So that will give me the net force, the magnitude of the net force. Okay. While the one force which is having the highest magnitude, that will basically show me the direction in which the object will move, right? Okay. Now let's say
Yes, sir.
that in this case, now both the boys were applying force of equal magnitude here. Let's say that this boy was applying a force of 50 Newton. This one was also applying a force of 50 Newton in opposite direction. Okay.
Yes.
And there are two forces acting here, force one and basically two forces, F and F here.
Hmm.
So the net force here will be what?
100. 100 newtons.
100 Newtons. No. We have to
Oh, sorry,
consider
0
the
newtons. 0
directions
newtons.
also. Yeah.
0 newtons.
We
We
have to
subtract the
consider
opposing forces.
exactly 50 Newton minus 50 Newton. That will be 0 Newton. And that means the body will be in rest
Rest.
position. Exactly. Got this thing? Okay.
Yeah. Yes, sir.
Okay. Apart from this, in the beginning, as I told you, that force can also have different effects to an object. Like it can change the position, size, and shape as well.
Yeah.
All right. Okay. Now remember this formula as I told you. Force equals to mass into acceleration.
Hmm.
Here is the mass of object and E is acceleration. Okay. So and don't get confused between the mass and weight, right?
Yeah.
Because both of them are two different things here. Okay. We can write it to be kilogram. Acceleration is SI unit is meter per second square. So
Hmm.
kilogram meter per second square. In short, we call it to be Newton, right?
Yeah.
So whenever someone asks you to expand this Newton, what does it equal to? So you guys can easily do that. That is kilogram meter per second square, right?
Yes.
Okay, good. Now let's talk about other. Okay, yeah. Let's talk about some of the energy changes. Like we talked now, this thing that the state of motion of an object can be changed, right? So, for example, this truck is at a stationary position here, and if a force
Yes.
is a push force is being applied, that is obvious that it will move in the right direction. Okay, but the motion is always considered with an observing point, right?
Yes.
So let's say I'm let's say I'm sitting on a bench here. Let's say I'm sitting on a bench here. Okay, so that is a stationary position. That is a stationary position, and nearby me on a road a bus is moving. A bus is moving. So how am I able to identify, how am I able to say that this bus is moving? Hmm? Like I can see that the bus is moving, my eyes can sense that, right guys? But in a scientific manner, how do we tell that this bus is moving? With a
From the mechanical
reference,
force.
not from the mechanical force. Look here, this bus is moving while this bench here, that is a stationary object on which I am sitting here. That is a stationary object now. Okay, so the position of this stationary object is not going to change since it is fixed. It is here.
Yeah.
While the
The rolling
position of the
resistance.
no, not rolling resistance. That is not what we're talking about here. Look here. Look, when this object here is moving now, it means that its position is changing. While its position is changing with respect to this stationary object. With time, the position of the bus is changing with respect to this stationary object. So from an observation point, we are looking at this bus to be moving. Getting it?
Yes. Hmm.
Okay. Okay, I hope that is clear. Hmm?
Yes. Yes, sir.
Okay. Or what if this bus was at rest position? So when this burst is not moving, that is, it is at rest. What does it says? It basically says that it is not changing its position with respect to this stationary object. So in that case, it will be having zero speed, and that means it is at rest. So this is
Yes.
how, in a scientific manner, we explain the motion of an object. So the motion of an object is always defined as the change of position of the object with respect to an observation point here. As you can see here, when the object starts moving, it means that its position is being changed with respect to an observation point. One more thing also you can add here, time here. Okay, with time also, the position of the object might change. Okay,
Yes.
okay. And there could be examples where the object is at rest while the time is still changing, right? So you have to consider both time and a reference point or an observation point also. Okay, so
Yes.
like from an observation point, if the distance of the object is changing, it means the object is at a position of motion, it is moving. Okay, any confusions in this one?
No. No, sir.
Okay, good. Now read activity 8.3. Who will read? Arham, you read this activity.
Yeah. Take a rubber ball and place it on a level surface such as a tabletop or concrete floor. Now gently push the ball along the level surface. Does the ball begin to move? Push the ball again while it is moving. Is there any change in speed? Does it increase or decrease? Next, place your palm in front of the moving ball. Moving ball touches it. Does your
Hmm.
palm apply a force on the ball? What happens to the speed of the ball now? Does it increase or decrease? What would happen if you let your palm hold the moving ball?
Hmm. Okay, so what are the conclusions we can draw from this activity, guys? Hmm?
So, if we apply force to the ball, it moves, while if we do not apply
force to the ball, it
Mhm.
does not move.
That is basically the simple conclusion from this, right? Okay, good, 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 Arhan. Okay, now talking about the change in the shape and size of an object here. Look, this is a stretched rubber band. Okay, or pressing a sponge or squeezing a spring. In this case, what is happening? Basically, the shape and size of the object is changing here, right?
Yes.
Okay, so if you were to take a spring here, okay, originally it is like this. Okay, so if you were to stretch it, you will be able to expand its size. Okay, so if you are taking this slide spring and pull it at both the ends with our hands, then the shape and size both are changing here, right? Okay,
Yeah.
so in this case, which force is occurring here? Basically the muscular force, no?
Yes.
Yes, sir.
Okay, yeah, right. What are some other examples in which the force can change the shape and size of an object? For
When
example,
we are
the
kneading a
Mhm.
dough, we are
Exactly,
kneading a dough or clay.
exactly. Okay, so a dough can be made into chapati
Yeah.
using using a balloon, right? That is also an example where we apply muscular force to change the shape. Okay,
Yes.
right. Okay, and other examples are like the pulling of cart by animals. That is also an example of muscular force. All
Yeah.
right,
Sir, how?
because it is basically being pulled by horses or buffaloes, no? So they are also applying the muscular force, no?
Sir, but you stated that muscular force also has
Mhm.
that ability to change its shape.
No, not muscular force. Any force has the ability to change the shape, size, direction, and motion of an object. Not necessarily muscular force. Muscular force is basically the
Oh,
force
okay.
applied by humans or animals, right? Okay.
Okay, sir. Yes,
Even
sir.
if an elephant is pulling heavy logs of wood, then there also he is using the muscular force, right? Okay.
Yes.
Now let's talk about the types of forces. Like in the beginning, as I said, that force will always be in action whenever two objects will have some interaction between them, between object A and between object B. If they are having some sort of interaction, that interaction
Yeah.
might either be in contact, or that interaction might be taking place if the objects are not in contact, in both the cases,
Yes.
right? So the first type of force is the contact type of force, right? So basically the
Hmm.
examples will be what? Hmm?
Muscle force.
Muscular force, that is also an example. Okay,
Frictional force.
frictional force, very good. What else?
And mechanical force.
Mechanic force also. Those are examples of contact forces where two
Yeah.
objects are in direct contact with each
Physical
other.
contact. Hmm.
Exactly. Then we have example of non-contact forces, like the gravitational force we are talking about. The gravitational
Hmm.
pull of moon acted that acts on the oceans. That is also an
Hmm.
example of
The
non-contact
tide.
force. Tides, right? No, tides is due to the gravitational pull. That is the
Yes, sir,
um,
I meant that.
yeah. And the magnetic force or the electrostatic force, right? So if you were to take a balloon and if you were to take some pieces of paper, chart paper, okay, and you rub them, then you will see that the pieces of a small paper will be attracted to this piece of balloon. So why is
Hmm.
it so? Because charges develop between the two bodies. Okay, or if you were to take a woolen cloth and you were to take a glass rod, you were to take a glass rod, the two objects will develop charges on them, and the objects will be start they will start to attract each other from a distance. So there is no contact
Yeah.
there. So these are
Hmm.
the examples of those types of forces where the two objects necessarily are not in contact with each other, yet they are exerting a force upon each other and pulling the body towards each other, or either repelling each other, right?
Hmm. Yeah.
Yes,
Okay.
sir.
All right. Okay. No. So let's discuss each of them in detail here. So first, let's talk about the muscular force. Okay. let's talk about first we will be starting our discussion with this contact forces. All right, guys.
Yes.
Okay. Okay. Muscular force. Okay. Now take example where a man is pushing, let's say a car is running. A car is running
Yeah.
by mechanical force. Okay. But if the
Mm.
car was to be not moving, then the a person is basically required to push it, right? So if a person is required to push that car, then the force acting here will be
Muscular force.
muscular force. So here it was mechanical force, right? But now if a person
Yeah.
were to basically push it, then that becomes muscular force, right? Other examples of muscular force are basically what? If the two boys are interacting and applying force on each other by pushing each
Mm.
other, if there's a fight between the two boys, that will also be an example of muscular force, right?
Yeah.
Or if
It's
a
like a game
man,
of football.
yeah, that will be also an example of muscular force. Or if a man was trying to pull or push a cow, that is also an example of a muscular force basically. Or if an elephant was to try to pull a log of wood, that will also be an example of muscular force, right? So
Yeah.
when a force of push or pull is applied by animals, specifically humans, then the force is called as muscular force,
Muscular force.
right? We have our examples here, like this man pushing this car. Okay, now why the figures you can see here in a tug of war also
Yeah.
muscular force is applied by the two groups, or whether this cart is being pulled by the buffaloes or ox, that is also the muscular force, right? Okay, then
Yes.
next comes the another type of contact force, that is a frictional force. Frictional force or simply friction, right?
Yes.
Frictional force
Yes.
or friction simply. So it is basically an opposing force now that resists the motion of an object, that resists the
Yeah.
motion of an object, right? So the force which always opposes the motion of one body over another body, like this two bodies A and body B, are lying over each other, and due to the surface roughness, due to the roughness between the two surfaces of the objects, they are not allowing each other to roll over, right? The surfaces are rough here. So surfaces, let's say the surfaces are like this. So they are somewhat interlocked between them. Getting it, guys? They are
Yes, sir.
interlocked between each other. That's why
Yeah. Hills
the
and
motion
valleys.
is exactly right like that. Okay.
Hmm.
So due to that, the two objects are unable to slide over each other. Okay.
Hmm.
All right. Now take some examples from daily life. Like if you were to ride a bicycle and if you were to stop pedaling a running bicycle, it
Hmm.
slowly and gradually it stops now after covering some distance
Yeah. Due to the friction.
due to the friction between the wheels of the bicycle and the road. Okay,
Hmm.
so that is another example. Or if you were to stop rowing a boat which is moving in water, it will also
Yeah.
start to stop down. No, it will also slow
Yeah.
down and then stop because somewhat frictional force is also acting between the water and the boat surface, base of the boat, right?
Yes. Hmm.
Okay, so that is basically frictional force. So we can define it like this: the force which always opposes the motion of one body over another body is called as Frictional force or
Friction
simply
force.
friction?
Friction.
Okay, now what is the reason behind the frictional force?
It
Yes, sir.
opposes the motion of the body.
No, the reason, the surface roughness, no?
Yeah,
what
due
did
to
you
the
say?
interlocking.
Yes, Arhan?
Sir, what did you say?
Here, the definition here, and then the reason that frictional force is basically due to the surface roughness, no?
Yeah, the interlocking between the two rough surfaces.
Exactly. The two surfaces basically gets interlocked into each other. Okay.
Yeah.
So the surface roughness decides the amount of frictional force. So the surface roughness, if it is more, then the amount of friction will be less, will be more, and if it
More.
is less,
Yeah.
if the surface roughness is less, then the amount of friction will also be lesser. Right.
Yes.
Okay, and
Yeah.
that can be the surface roughness can be reduced by addition of lubricants. Right. Okay. Okay. Now let's come to this air resistance here. Right. Air resistance. Okay, so what is this here now? So this is also an example of contact force here, right? So whenever there's a flight, okay, basically three types of forces are acting on this airplane here. One is the force of gravity, that is the pulling force towards the earth. Another one is the
Yeah.
thrust, the force by which the airplane is moving in forward direction,
Mm.
forward motion, and then the resistance that is being offered by the air. So here also we can consider it to be an example of friction also. Okay.
Mm.
So the friction offered by the air, it is simply called as air resistance, guys. Okay.
Yes, sir.
So
Yeah.
that is another example of a contact forces. Okay. So basically, you will see that here air resistance, to minimize the air resistance, the body of the aeroplane is of streamline shape now.
Yeah.
Streamline shape that
Yes,
is
sir,
similar
it
to the
cuts
shape of a
through the
fish.
air.
Yeah, it basically cuts through the air, or
For
also,
aerodynamics.
yeah, basically the concept of aerodynamics is applied here.
Hmm.
Ahmed. Okay, and also the rockets, which you see, the rockets and the missiles, they also have a very pointy head. Okay, why? Because to minimize the air resistance. Okay,
Yes, sir.
all right. Now next is basically the non-contact forces, that were the magnetic force, electromagnetic force, and then the gravitational force, right guys?
Electrostatic.
Yes.
Yeah, electrostatic
Hmm.
force as well. So
Yeah.
non-contact forces. Okay, so the forces which we were talking so far, that we see that the agent applying a force on an object, we should always be in contact with it, which we
Yeah.
were
Physical contact.
that was the contact forces, but it is not always necessary that the agent applying a force on an object will be in contact. Okay, so there
Yeah.
are some forces which acts on an object at a distance.
Hmm.
Okay, so we say it to be a force which can be exerted by an object on another
Sir, is
object.
gravitational force the answer?
Yeah, exactly, that is an example here. Okay, so even from a distance without touching each other, touching is called a non-contact force.
Yes, sir.
Okay, and the examples were magnetic force, then you had example of electrostatic static force. Okay, that is due to the charges. And you guys do tell me, charges develop to which subatomic particle?
Sir,
Negative and
electrons are
positive.
protons.
Negative and positive charges are there.
Sir,
Good.
Yeah.
electrons and protons.
Yeah, electron and proton, to be more specific. Right.
Yeah.
Okay, so in an atom, you see that there are three subatomic particles: protons, neutrons, and electrons. So in the
Electrons.
nucleus of an atom, you see the protons and neutrons are together in the nucleus,
Nucleus.
while in their orbit, electron, that is a negative particle, it revolves around. Right. So
Yeah.
the proton or neutron are fixed; they cannot escape the atom. They are fixed inside the
Hmm.
nucleus, while this electron can escape from one atom to another atom.
One other. Hmm.
Okay, to another atom. So suppose if another atom is having a deficiency of some electrons, it requires some electrons, right? So this electron
Yeah.
will transfer to the another atom. Getting it, guys?
Yes.
So in
Yes,
this
sir.
case, transfer of charges takes place from one body to another. Suppose this atom belong to body A, this atom belong to body B, right?
Hmm.
So this some amount of electron transfer from electron body A to body B. So now if some electrons are transferring from this to this, so this will have a deficiency of electrons now. Okay,
Yeah.
and we know that an atom has both positive and negative charges, right? So some of the negative charges, if it transfer to this one, so that means basically body A will have a deficiency of negative electron, so the net
Hmm.
amount of charges will be positive now.
Yes,
There will
sir.
Yeah.
be more now, right? So earlier, let's say there was 10, now there was 10 electron and 10 proton. Now one was transferred to this one, so that means it is having only 9 electrons. So it is having a positive charge now, one positive
Yeah.
charge,
Yes,
and
sir.
it will
Hmm.
have one extra negative charge, right? So one negative charge. So this is how bodies develop charges on them, and how electricity, basically the concept of electricity is based on the transfer of electrons from one place to another. Okay.
Yeah.
Okay, so we will discuss each of them. So first talk about the magnetic force, right?
Hmm.
Yeah. Yeah. So you see, what is a magnet? It is basically a type of substance that attracts things made up of iron or steel.
Yeah.
Any substance that is made up of iron or steel, it will be attracted by this, by a magnet.
Magnet. Yeah.
So
Sir,
if we were to
it
Mhm.
also repels, not only attract.
No, to iron objects, it will only attract. In
Yeah.
every situation,
Iron, nickel,
iron
and
objects will
cobalt.
be, yeah, objects made up of iron or objects consisting of some amount of iron will get attracted to a magnet. So if you have some iron nails or pins, if you were to move them towards a magnet, they will be attracted to it,
Yeah.
right? Okay. So basically here what is happening, this magnet must be exerting some force on them now.
Hmm.
Magnet here, and these are pins here. Okay, so this force that is being exerted by a magnet is simply called as magnetic force. Magnetic force. Okay, and it acts from a distance. It may act even from a distance. Okay,
Hmm.
so objects which are made up of iron, steel, or whether it's made up of nickel or even cobalt, right? So these objects are known to be getting attracted to a piece of magnet. Okay,
Yeah.
and it will not attract objects which are made up of, for example, wood or glass, objects which
Sir,
are
copper is also an substance which magnet attracts to.
no, copper is not getting attracted by a magnetic substance, by a magnet. Copper, wood, or piece of glass, right, or piece of glass, these substances are not attracted by a magnet. Getting it? Okay.
Yes, yes,
All right. So now,
yes, sir.
why the reason why we have put it under the category of a non-contact force, because it can act from a distance. Okay. So since a magnet can exert its magnetic force on iron objects. By the way, do you guys know the name of ore of magnet?
Yes, sir.
What is the ore from which magnet is derived? Ore.
Iron, nickel, and cobalt.
Oh, no, that is not the name of the ore. For example, aluminum.
Copper.
No,
Oh,
ore is a completely different thing. In the
So,
chapter
sir,
metallurgy, you guys will be studying that in higher classes. There's a chapter called metallurgy in which you guys will be studying about minerals and ores. Let me give you guys an idea of that. So minerals and ores here. Okay, so suppose you have aluminum, that is a mineral. Okay, so do we get aluminum in pure form in nature? Yeah, do we get this in pure form like petrol? We do not get it is not found in pure form in
You
nature.
get it crude
sir,
for
is
oil.
magnetite
Yeah,
an example of ore or magnetic ore?
exactly, that is correct. Okay,
oh,
so look, ore is basically a rock. It is basically a
Hmm.
rock from which this metal aluminum has been extracted, or it might be another metal like iron as well. So ore is
Hmm.
simply a rock which consists of so many impurities. Okay, it might be consisting of some rock materials. Apart from rock materials, it might be having iron, cobalt, or it might be having aluminum, right? So suppose a piece of rock had 100 gram of aluminum and 1 gram of cobalt, 1 gram of iron, and 5 gram of
Hmm.
rock materials. So we will say that it is a ore of aluminum since the maximum amount of aluminum is found in it. Getting it?
Yeah.
So
Hmm.
the ore of aluminum, the rock from basically which aluminum is extracted, that is called as bauxite. Okay.
Hmm.
Similarly,
Yeah.
you have different types of ores for iron as well. Some of them are hematite, right? Another one
Hmm.
is magnetite. So magnetite is the same ore from which magnets are derived.
Yeah.
All right. Okay, so that is the thing which I was talking about. Now coming back to our discussion here, that since a magnet can exert its magnetic force on iron objects from a distance, okay, that is even without touching them, okay, therefore we classify the force exerted by it to be a non-contact force.
Yes, sir.
Okay. All right. So that is it. Okay. And do you guys know who discovered the phenomena of force? Like this thing. No, there was a scientist called
Sir,
Isaac Newton. No,
yes,
who
sir. Yes,
discovered
sir.
what was the
Yeah.
type of
Isaac
force
Newton.
discovered by him? Isaac Newton.
Law.
The
Motion
gravitational
law.
force.
Gravitational force exerted by the Earth. Right.
Yeah.
Okay. So it is the
Yes,
gravity,
sir.
force of gravity that causes all objects to fall back towards the Earth.
Yeah.
Right. Okay, so that one we will also discuss in next class then. Okay, so I got there's one question for you guys. I need you guys to solve it. Okay, yeah. So I'm writing the question here. Okay, okay. Let's say that there is a bus. Okay, let's say that there is a bus. Okay, and that is moving at a speed of the acceleration of that bus is basically 10 meter per second square. That is its acceleration.
Hmm.
All right. Okay, and the weight of this bus combined with the passenger, it is, let's say it to be 500 kilogram. All right. So the driver of the bus basically applies a brake here. Okay. To tell me what is the force here, the force with which the brakes was applied on the bus. And you guys know?
Magneticial.
The mechanical force.
No,
Oh,
no, no.
mechanical.
I'm asking you to calculate the magnitude. You guys know force equals to mass into acceleration, no?
Yeah.
Okay. So mass here was how much? 500 kilogram. 500 kilogram. Acceleration is 10 meter per second square.
10 meter. Yeah.
So the force will be 5,000
5,000
kilogram
meter.
meter
5,000.
per second square, right? Or
Yeah.
we can simply call it to be
5,000
5,000
Newton.
Newton. All right, guys. Okay,
Yeah.
then that's it for today. In next class,